Hi students, welcome back to the Google Classroom of Plus One Statistics, Chapter 4, Presentation of Data. Good morning to all. In the last class, we have learnt about the tabular presentation of data and the important parts of a good table. What are the important parts of a good statistical table? Table number, title, captions or column headings, steps or row headings, body of the table, unit of measurement, sources, and the footnote. Today, we will focus on the topic diagrammatic presentation of data. There are various kinds of diagrams in common use. The most important among them are geometric diagram, frequency diagram, and arithmetic line graph. Geometric diagram includes bar diagram and pie diagram. Then bar diagram can be also classified into simple bar diagram, multiple bar diagram, and component bar diagram. Our next topic is diagrammatic presentation of data. This is the third method of presenting data. This method provides the quickest understanding of the actual situation to be explained by data in comparison to tabular or textual presentations. Diagrammatic presentation of data translates quite effectively the highly abstract ideas contained in numbers into more concrete and easily comprehensible form. Diagrams may be less accurate but are much more effective than tables in presenting the data. There are various kinds of diagrams in common use. The most important ones are geometric diagram, frequency diagram, and arithmetic line graph. This includes graphs and diagrams. Diagrams, bar diagram, and pie diagram. Bar diagram includes simple bar diagram, multiple bar diagram, component bar diagram, percentage bar diagram, and deviation bar diagram. Then graphs, histogram, frequency curve, frequency polygon, ogives, and line graph. So these are the different kinds of graphs and diagrams. So first one is geometric diagram. Bar diagram and pie diagram come in the category of geometric diagram. There are different types of bar diagrams, but you have to study only three types this year: simple, multiple, and component bar diagrams. First one, bar diagram or bar chart. Bar diagram consists of a series of rectangular bars of equal width. These are a series of rectangular bars with equal width. The bars stand on common baseline with equal gap between one bar and the other. The bars may be either horizontal or vertical. Bars may be either horizontal or vertical. The bars are constructed in such a way that their lengths are proportional to the magnitudes or frequencies. A good bar diagram should essentially have these following. Space between consecutive bars are equal and the first one is simple bar diagram. This simple bar diagram is used to represent when items have to be compared with regard to a single characteristic. Here, the items are represented by rectangular bars of equal width and height proportional to their magnitude or frequency. The bars are drawn on a common baseline with equal distance between the consecutive bars. The bars may be shaded. In short, bar diagram comprises a group of equispaced and equiwidth rectangular bars for each class or category of data. Height or length of the bar reads the magnitude of data. The lower the end of the bar touches the baseline such that the height of the bar starts from 0 unit. Bars of a bar diagram can be visually compared by their relative height and accordingly data are comprehended quickly. Children, look here. This is an example of simple bar diagram. On the x-axis, we mark different kinds of fruits, and on the y-axis, the number of people. Then make rectangular bars of equal width and height proportional to the magnitude or the frequency. This is another example of simple bar diagram. Transport to school. This simple bar diagram shows the number of ways children travel to school in one of the classes. On the y-axis, we mark the frequency or the magnitude of this data. Different types of data may require different modes of diagrammatical representation. Bar diagrams are suitable both for frequency type and non-frequency type variables and attributes. Discrete variables like family size, spots on a dice, grades in an examination, etc., and attributes such as gender, religion, caste, country, etc., can be represented by bar diagrams. Bar diagrams are more convenient for non-frequency data such as income expenditure profile, export or imports over the years, etc. Another important one is multiple bar diagram or compound bar diagram. When there are two or more different comparable sets of values, multiple bars are drawn. For example, imports and exports. So, in this example, we can use this multiple bar diagram. Here, sets of rectangular bars of equal width with height proportional to the value are drawn. The bars corresponding to the same unit are placed together adjacent to one another. So, this is the example of multiple bar diagram. Here, 4 components are there. So, these bars corresponding to the same unit are placed together adjacent to one another. The diagram is shaded properly and an index is provided. So, children, look at this picture. This multiple bar diagram depicts 4 sets of data like north, south, east and west. So, we have to use 4 different shades for these 4 sets of data: north, south, east and west. This is another example of multiple bar diagram. This example shows the strength of the students based on gender classification in nursing degree course. First BSc, second BSc, third BSc and fourth BSc. So these 2 sets of data are here, boys and girls. So we have to use 2 different shades for boys and girls, and we can understand easily the strength of the students based on this gender classification. Next one is component bar diagram. To represent items whose magnitudes have 2 or more components. The comparison of components are expressed as percentages of the corresponding totals. The totals are represented by bars of equal width and height equal to 100 each. These bars are divided according to the percentage components. The different subdivisions are shaded properly and an index which describes the shades is provided. Percentage bars are useful in comparing percentage components. So this is an example of component bar diagram. An example shows preference of extracurricular activities the students in nursing course based on gender. So children, these are the 3 extracurricular activities of the students: dance, TV and sports. So on the basis of this gender, men and women, these 3 extracurricular activities, dance, TV and sports, are depicted here in this percentage or component bar diagram. These component bar diagrams or charts are also called sub-diagrams and are very useful in comparing the sizes of different component parts and also for throwing light on the relationship among these integral parts. Children, look at this picture. This is the table 4.7 of your textbook, page number 48. The bar might show the total population of children in the age group of 16 to 14 years. The components show the proportion of those who are enrolled and those who are not. A component bar diagram might also contain different component bars for boys, girls, and the total children in the given age group range. To construct component bar diagram, first of all, a bar is constructed on the x-axis with its height equivalent to the total value of the bar. Otherwise, the height is equated to the total value of the bar and proportional heights of the components are worked out using unitary method. Smaller components are given priority in parting the bar. Children, look at this picture. This is figure 4.3. To construct a component bar diagram, first of all, a bar is constructed on the x-axis with its height equivalent to the total value of the bar. For percent beta, the bar height is of 100 units. So here all these three bars, the height of all these three bars is of 100 units. So first we have to mark 91 percentage and then 8.5 percentage. So the total 100 units. Then next one 58.6, then 41.4, 100 units. Then next one 78.0 and 28.0. So the total is 100 units. Let us conclude today's session by recollecting all the concepts. What do you mean by bar diagram or bar chart? It consists of a series of rectangular bars of equal width. Simple bar diagram used to represent when items have to be compared with regard to a single characteristic. The next one, multiple bar diagram or compound bar diagram. When there are two or more different comparable sets of values, multiple bars are drawn. Then component bar diagram to represent items whose magnitudes have two or more components. We use this component bar diagram. So children, please note that the corresponding URL, notes of the lesson and test paper are also attached along with this video. Make use of all these available resources, study well and attend the test paper without fail. Thank you.